last class, yesterday we worked on finding the perimeter. Now we are going to work on finding the area of different shapes. So right in front of me, we have a composite figure. Composite figure means that you have two or more different shapes or same shape that are combined. Now, for finding the area of a composite figure, you always have to divide it into regular shape or regular polygon, or different, because they're combined, right? So you have to divide them up, and then so you can either add or subtract. So let's take a look at number 1A. So this is like the same questions from yesterday. So we can able to find this length by doing 9 minus 4, because these two are the horizontal line. So this is 5 meters. And then to find this length, we know another vertical lines are 8 and 3. So 8 minus 3 is also 5 meters. Now to find the area, we got to divide it up. So I could divide it into two regular shapes. So this is shape number 1 and this is shape number 2. So to find the area, the total area is area number 1 plus area number 2. So the area for this is a rectangle, so length times width, and this is also a rectangle, length times width. So then it will be 8 times 5, so this is 8 times 5. And then this is going to be 4 times 5. And therefore 40 plus 20, and you'll be getting 60. And because it's area, the degree has to be 2, 60 meters squared. Now let's take a look at number 2A. Find the area of a figure to the nearest unit. So we learned about rounding yesterday. Nearest unit means that it has to be rounded to whole number, no decimal. So identify that we have two different shapes. The area of a total, in this case, we have a rectangle. And then we have a semicircle. Two shapes. So area of the rectangle, the formula is length times width. And the area of the semicircle is 1/2 times pi r squared. So I divided it by 2 because it's a semicircle. So pi r squared is the area of a circle, and then multiply that by half. Now let's see, the length is 2.7 and the width is 1.9 plus pi times r. So in this case, it's not labeled on the circle, but we know if this is 2.7, this must be also 2.7. That is the diameter. So to find the radius, we need to do 2.7 divided by 2. And that will give me 1.35 meter. So 1.35 squared, which is the radius, right? And I'm going to replace that with square bracket, divided by 2. And then when you multiply these two and then add this 2, okay? So make sure you double check using your calculator. The area is equal to 8 meter squared. Okay. Okay, next. Number 3. Find the area of a shaded region to 1 decimal place. So now we are looking at only the shaded area. So again, we need to figure out what are the different shapes divided up. So it looks like I have shape number 1, which is a small circle, and I have area number 2, which is the whole big circle, the large circle here. Okay, so small circle, which is area number 1, and big circle, area number 2. So to find the shaded area, or area, rather than writing T, let's write shaded, is equal to, well, all we need to do is subtract, right? The big one minus the small one. Then you get the shaded one. So area of the big circle minus the area of the small circle. Or you could label it with 1 and 2. Now the area of a circle is pi r squared. And again, the area of a circle is pi r squared. Now let's find the area, the radius of a big circle. So it looks like the radius of a big circle is 4.3. So pi times 4.3 squared minus pi, the radius of a small circle, it looks like it's 2.4. 2.4 squared. Now don't forget, it's 4.3 times 4.3. And then you use the pi button on your calculator. Once you do that, you will get 39.99. And if I have to round it up, if I round 9, it's going to round to 10. So it's going to be 40.0, which is 1 decimal place, centimeter square. And that is your final answer. Okay, let's try one more. So number 4, it says find the shaded area to 1 decimal place. Okay, again, let's identify what are the shapes within this composite figure. So it looks like I have a parallelogram. And then within the parallelogram, I have a triangle. So to find the shaded area, A of the shaded, it must be, I have to find the area of the parallelogram and subtract the area of a triangle. So look at your formula sheet, and the area of a parallelogram, it says base times height, and the area of a triangle is base times height divided by 2. So let's identify these variables for parallelogram. So the parallelogram, so this is 4.3, and then this is 5.8. So to find the entire height, it must be 4.3 plus 5.8, and that will give me 10.1 meter. And then the base of the parallelogram, it looks like it's 10.2. So 10.2 times 10.1 minus, now the base of a triangle is 10.2, and the height of the triangle is 5.8. And then you divide it by 2. Okay, so once you multiply everything and then do the bed mass, you will get 73.4 meter squared for your shaded area. Okay. Now this will be the homework below, which is going to be a textbook questions. So keep in mind, to find the area of any composite figure, always divide it into different shapes, and then you can either add or subtract. The next lesson, after finding the area, we're going to understand how to find the volume. Area is how much the space it takes up for 2D. But for volume, it's about understanding, it's another word for volume is a capacity, how much it fills up in a 3D shape. Okay, so area is always going to be 2D, unless I'm talking about surface area. Surface area is finding the area for all the outside shape, for which is in this case we're going to talk about specifically for 3D shape. And for volume is how much volume capacity, or how much area, how much space it takes up within the 3D shape. So take a look at your formula sheet. You will notice that for volume of, let's say, a rectangular prism, okay, so these are all prism. And think of prism like this. When you have a 2D shape, and if I were to stretch this 2D shape to the back, then what you're producing is a prism. This is terribly drawn. Okay. So as you can see, identify the base first. So in this case, the base is rectangle here, and it has been stretched. Again, the base of this shape is a pentagon, and it has been stretched by height. Again, for cylinder, the base is circle, and it has been stretched by height as well. So all you're doing is just stretching the base to produce a prism. Now, on the other hand, if we're talking about pyramids, you have a base, a regular shape, anything like a square or rectangle, but they have like a triangular sides. So they are pointy at the top. And one interesting thing about pyramid is that they are always 1/3 of the volume of the prism with the same base and the height. So in this example, we have a rectangular prism over here, right? This whole thing is rectangular prism. But inside, you will notice that you have a triangular prism, rectangular pyramid. So this rectangular pyramid is going to be 1/3 of the volume of the prism. Always 1/3. So what does that mean? If I were to put 3 of this pyramid into this prism, and that's how it's going to be equal to. So 3 of this pyramid of the same base, it must be a same base, is equal to 1 volume of the prism. And I'm going to write must be same base. Okay. Same thing for cone as well. Cone and pyramid, they follow the same idea. And lastly, we have sphere. Sphere is an interesting one. This is the formula. It's like a ball, any kind of a 3D ball shape. Okay. Now let's try some sample calculations. So we could go over, let's say, letter C. So calculate each volume. So in this case, identify the base. It looks like my base is a trapezoid, and it has been stretched by 4.8 meter. So this must be the height of the trapezoid. So the volume is always the area of the base times height for any type of prism. All prism. So the area of the base, in this case, is a trapezoid. So trapezoid is HA plus B over 2. That's a trapezoid. Times the height of the pyramid prism. So in this case, I'm going to write it in capital H. This capital H represents it's the height of the prism, not the base. Okay, so that means how much it has been stretched by. So now that we have labeled it correctly, let's plug in the numbers. So h, small h, represents the height of the trapezoid, in this case, 3.6. And then replace the round bracket with square bracket, a, which is 4.1, plus b, which is 7.2, and then divided by 2, times the height of the prism must be 4.8. That's how much it has been stretched. So when you are doing this calculation, make sure you add these two first. Add these two first, and then multiply 3.6, and then divide it by 2, and then you can multiply that by 4.8 last. When you do it, volume is going to be equal to 97.6 meter cube. Don't forget, the degree for volume must be 3. Now, next one. So let's try the pyramid. So we could try the pyramid for D. So as you can see, it looks like I'm given a square base pyramid, because it looks like this is 10.5 and this is also 10.5. So look at your formula sheet. If not, the volume is 1/3 times the area of the base times height, right? Because it's always the 1/3 of the prism's volume. So 1/3 times the area of the base, in this case, it's a square. So square must be s squared times the height, which is 21. So let's plug it in. 1/3 times s, which is 10.5 squared, times 21, the height of the pyramid. And once you punch everything in, so what you could do is 10.5 times 10.5, and then divide it by 3, and then times 21. And volume is equal to 771.8 centimeter cube. Okay, good. Now, number 2 is an interesting one. So let's take a look at number 2. So we are given a sphere that just fits inside of an 8 centimeter, 8 by 8, a cubic box. So what percent of the box is empty to the nearest tenth? So what we're looking for is we need to figure out the volume that's empty, that is not taken up by the sphere. So to find the empty the volume capacity, well, first we need to figure out volume of the empty is equal to volume of the box minus the volume of the ball or the sphere in this case. Then you'll be able to get the volume that has not been taken up. So the volume of the box, which is a cube, it's going to be length times width times height. So in this case, s cubed. They're all the same. Minus the volume of the sphere is 4 pi r cubed divided by 3. So s is 8 cubed minus 4 pi, radius is, so if this is 8, so from here to here, because it fits just right perfectly within the cube, so it must be the half of the length. So the radius must be 8 divided by 2, which is 4. So radius is 4 cubic divided by 3. Now don't forget, for cubic, it means 8 times 8 times 8. And then once you do the calculation, you will get 243.9 centimeter cube. So that is the empty volume. But the question is saying, what is the percentage? How much is the volume empty? Well, to figure out the percentage, the second step is now percentage of empty space, volume, space, is dependent on the entire volume of the box. So we got to divide it. So the volume of the entire box, or yes, over the volume of the empty space. And then you're going to times it by 100%. So empty is 243.9 over the volume of the box, which is 8 times 8 times 8, 512 times 100%. So once you divide it and times that by 100, you will get approximately 48%. So because it's a word problem, you have to end with a sentence. So therefore, about 48% of the box is empty. And that is your final answer. Okay. Now, for number 4, if you look, now I wouldn't, right now we are, we didn't go over like polynomial unit per se, so I wouldn't stress about number 4. Don't worry about number 4, okay? But I would like to still show you how to do number 4, just for your understanding, okay? Now, the volume of a rectangular prism is represented by 12x cubed. So you will notice that there's no number. It has a variable. And then the question is saying determine an expression. So expression means that it contains a variable and a number. So for example, 3x plus 4, this is an expression. This expression is separated by plus or minus. The terms, so we have two terms, 3x and 4, and the terms are separated by plus or minus. And when we put them together without an equal sign, this is called an expression. And they're saying determine the expression for the area of the base if the height is represented by 3x. So let's write down what we're given in the question. So it looks like the height of the prism is 3x, and we know that the volume is 12x cubic, and they want us to write down the expression for the area. Area is equal to question mark. Okay. So we know what the volume is. So let's write down the volume formula, the equation for a rectangular prism. So if you look back to your formula sheet, the volume of a rectangular prism is the area of the base times the height. So the base in this case is, this is what we're looking for, right? This is what we're saying. And so in order to isolate for base, we gotta rearrange. So I'm going to move times h by other side. So opposite of multiplying, you gotta divide it by h. So let's divide both sides by h. And then h and h cancels out. So therefore, volume divided by h is equal to the area of the base. And then we can plug it in. So volume is 12x cubed, and then h is 3x. Now, I know we didn't learn this, but just for your understanding, so that we can be prepared for upcoming chapters, when we are dividing a term, different terms with variable, you do the numbers first, the coefficient. So 12 divided by 3 is 4. And when you have a same base, x cubic divided by x, there's this invisible 1 here. Okay, we never write 1. So when I say x, x essentially means x to the 1. They're invisible. And when you're dividing a same base with an exponent, the base stays the same, but all you're doing is you're subtracting the exponent. So 3 minus 1. So therefore x squared. And this is the exponent law we're going to learn later on. Okay, but I thought I would just put it out there. So if anyone is curious, then this is how you do it, using the exponent law. And this is exponent law that we are going to learn next chapter.